Any pair of points can be connected by a line segment. That's right. Connect two pairs of black points in a way that creates two parallel line segments. So let's see if we can do that. So I could create one segment that connects this point to this point, and then another one that connects this point to this point, and they look pretty parallel. In fact, I think this is the right answer. If we did it another way, if we had connected that point to that point, if we connected that point to that point and this point to this point, then it wouldn't look so parallel. These clearly, if they were to keep going, they would intersect at some point. So let me set it back up the way I did it the first time. Let me make these 2 points. Let me make these 2 points parallel. And these are line segments because they have 2 endpoints. They each have 2 endpoints, and they continue forever. Well, they don't continue forever. They continue forever in no directions, in 0 directions. If it was a ray, it would continue forever in one direction. If it's a line, it continues forever past both of these points. In fact, it wouldn't have endpoints because it would just continue forever in both of these directions. Let's do one more. Drag the ray so it has an endpoint at A. So we want to make its endpoint at A where the ray terminates and goes through one of the other black points. The ray should also be parallel to the pink line. So I have 2 options. I can make it go through this black point, but it's clearly not parallel. In fact, it looks perpendicular here. So let's try to make it go through this point. Well, yes, when I do that, it does indeed look like my ray is parallel to the pink line. And this is a ray because it has one endpoint. This is where the ray terminates. It's an end point. It literally ends there. And it continues forever in one direction. In this case, the direction is to the right. It continues forever to the right. So it continues forever in one direction. Any pair of points can be connected by a line segment. That's right. Connect two pairs of black points in a way that creates two parallel line segments. So let's see if we can do that. So I could create one segment that connects this point to this point, and then another one that connects this point to this point, and they look pretty parallel. In fact, I think this is the right answer. If we did it another way, if we had connected that point to that point, if we connected that point to that point and this point to this point, then it wouldn't look so parallel. These clearly, if they were to keep going, they would intersect at some point. And goes through one of the other black indeed look like my ray is parallel to the pink line. And this is a ray because it has one endpoint. This is where the ray terminates. It's an end point. It literally let's say we have one ray over here that starts at point A and then goes through point B. And so we could call this ray, let me draw that a little bit straighter. We could call this ray AB. Ray AB starts at A or has a vertex at A. And let's say that there's also a ray AC. So let's say that C is sitting right over there. And then I can draw another ray that goes through C. So this is ray AC. And what's interesting about these two rays is that they have the exact same vertex. They have the exact same vertex at A. And in general, what we have when we have two rays that have the exact same vertex, you have an angle. And you're probably already reasonably familiar with the concept of an angle, which I believe comes from the Latin for corner, which makes sense. This looks like a little bit of a corner right over here that we see at point A. But the geometric definition, or the one that you're most likely to see, is when two rays share a common vertex. And that common vertex is actually called the vertex of the angle. So A is vertex. Not only is it the vertex of each of these rays, ray AB and ray AC, it is also the vertex of the angle. So the next thing I want to think about is how do we label an angle? You might be tempted to just label it angle A, but I'll show you in a second why that's not going to be so clear to someone based on where our angle is actually sitting. So the way that you specify an angle, and hopefully this will make sense in a second, is that you say angle, this is the symbol for angle, and it actually looks strangely similar to this angle right over here. But this little pointy thing, or it almost looks like a less than sign, but it's not quite. It's flat on the bottom right over here. This is the symbol for angle. You'd say angle BAC, or you could say angle CAB, or angle CAB. In either case, they're kind of specifying this corner, or sometimes you could view it as this opening right over here. And the important thing to realize is that you have the vertex in the middle of the letters. Now you might be saying, wait, why go through the trouble of listing all three of these letters? Why can't I just call this angle A? And to see that, let me show you another diagram. And although the geometric definition of an angle involves two rays that have the same vertex, in practice, you're going to see many angles that are made up of lines and line segments. And you can imagine that you could continue those line segments on and on in one direction, and then they would become rays. So in that way, they're consistent with this definition. But let's say I have one line segment that looks like that. Let me label some points here. So we've already used A, B, C. So let me call this D and E, points D and E. So this is line segment DE. And let's say I also have line segment, FG. And let's say this point where these two line segments intersect, let's call that point H. Now how could we specify this angle right over here? Can we just call that angle H? Well, no, because angle, if we just said angle H, the angle that has a vertex H, it could be this angle right over here, or it could be this angle right over here. Let me draw it this way. You could view it that way, or it could be this, it could be that angle over there, it could be this angle over here, it could be this angle over here, or it could be that angle over there. And so the only way to really specify which angle you're talking about well is to give three letters. So if you really did want to talk about that angle right over there, you would call that angle EHG. So that is angle EHG, or you could actually specify that, or you could call that angle GHE. GHE. If you wanted to specify this angle right over here, if you wanted to specify that angle right over here, the one made up of, if you imagine that ray and that ray, if you were to keep on going past those points, then you could call that angle DHG, angle DHG, or angle GHD, or angle GHD. I think you get the point. This angle up here could be FHE or EHF, and this one could be FHD or DHF. And when you do it this way, it's very clear what angle you are referring to. So now that we have a general idea of what an angle is and kind of how do we denote it with symbols, the next thing you might be curious about is it doesn't look like all angles are kind of the same. It seems like some angles open up or are more open than others, and some are a little bit more closed in than others, and that actually is the case. So for example, let's take two angles here. So let's say I have one angle that looks like that. So I'll start reusing letters. So let's say that this is A, B, and C. I could make these rays. I could keep on going and make them rays if I like, or I could just keep them as line segments. So right over here I have angle BAC, and let's say over here I have angle, so let me draw another one, and let's say this is angle XY, angle XYZ. And once again, I could draw them as rays if I like, to go on and on and on. So it's angle X, Y, and Z. And so when you just look at these, you just eyeball these two angles, it looks like this one is more open. So this one looks more open, while this one over here looks more closed. So it looks like it's more closed, at least relative to this one, more closed. So maybe when we measure angles, we should measure it based on how open or closed they are. And that actually is the case. And so without even telling you how we measure an angle, you could say that the measure of angle XYZ, the measure of this angle, is greater than the measure of this angle right over here. And any convention we use for measuring angles is essentially going to be a measure of how open or how closed an angle actually is. And I'll take that up in the next video where we'll see how to actually measure an angle. What is another name for angle CPA? So we have C, we have P, and we have A. So angle CPA is going to be this angle right over here. So what's another name for it? Well, I could start off with A, and I could call it angle APC. So this is the same thing as angle APC. Now, is that any one of my choices? Yeah, that's this choice. That's this choice right over here. If someone said angle P, that wouldn't give you a lot of information. That kind of says, well, you know, that's only giving me 1 point. I don't know, maybe it's referring to that angle, that angle, that angle, that angle. So that's really not giving me enough information to specify this angle right over here. Angle PAC would be an angle formed if you actually had a line here. If you had a line between AC, angle PAC would be this angle right over here, which is clearly a different angle. Angle FPA would be this angle right over here, which is also clearly a different angle. So the only choice that makes sense is angle APC. Now that we know what an angle is, let's think about how we can measure them. And we already hinted at one way to think about the measure of an angle in the last video, where we said, look, this angle XYZ seems more open than angle BAC. So maybe the measure of angle XYZ should be larger than the angle of BAC. And that is exactly the way we think about the measures of angles. But what I want to do in this video is come up with an exact way to measure an angle. So what I've drawn over here is a little bit of a half circle, and it looks very similar to a tool that you can buy at your local school supply store to measure angles. So this is actually a little bit of a drawing of a protractor. And what we do in something like a protractor, and you could even construct one with a piece of paper, is we've taken a half circle right here and we've divided it into 180 sections, and each of these marks marks 10 of those sections. And what you do for any given angle is you put one of the sides of the angle. So each of the rays of an angle are considered one of its sides. So you put the vertex of the angle at the center of this half circle, or if you're dealing with an actual protractor, at the center of that protractor, and then you put one side along the 0 mark. You put one side along the 0 mark. So I'm going to redo this. I'm going to redraw this angle right over here at the center of this protractor. So if we said this is y, then z goes right over here, and then the other ray ray yz or ray yx in this circumstance, will go roughly in that direction. And so it is pointing on the protractor to the, let's see, this looks like this is the 70th section, this is the 80th section, so maybe this is, I would guess the 77th section. So this is pointing to 77 right over here. And so when we measure an angle, so we could say the measure of angle XYZ, assuming that I drew it the right way right over here, we could say the measure of angle XYZ. Sometimes they'll just say angle XYZ is equal to, but this is a little bit more formal. The measure of angle XYZ is equal to 77. And what we do is we call each of these little sections, we call them degrees. So it's equal to 77. Sometimes it's written like that, and the same way you would write degrees for the temperature outside. So you could write 77 degrees like that, or you could actually write out the word right over there. So each of these sections are a degree, so we're measuring in degrees. And I want to be clear, degrees aren't the only way to measure angles, really anything that measures the openness. So when you go into trigonometry, you'll learn that you can measure angles not only in degrees, but also using something called radians. But I'll leave that to another day. So let's measure this other angle, angle BAC. So once again, I'll put A at the center, and then AC, I'll put along the 0 degree edge of this half circle or of this protractor, and then I'll point AB in the, well, assuming that I'm drawing it exactly the way that it's over there. Normally, instead of moving the angle, you could actually move the protractor to the angle. So it would look something like that. And you could see that it's pointing to right about, well, let's just say right about the 30 degree mark. So we could say that the measure of angle BAC is equal to 30 degrees. And so you can look just straight up from evaluating these numbers that 77 degrees is clearly larger than 30 degrees, and so it is a larger angle, which makes sense because it is a more open angle. And in general, there's a couple of interesting angles to think about. If you have 0 degree angle, you actually have something that's just a closed angle. It really is just a ray at that point. As you get larger and larger, or as you get more and more open, you eventually get to a point where one of the rays is completely straight up and down while the other one is left right. So you could imagine an angle that looks like this. You could imagine an angle that looks like this, where one ray goes straight up down like that, and the other ray goes straight right left. Or you could imagine something like an angle that looks like this, where at least the way you're looking at it, one doesn't look straight up down, or one doesn't look straight right left, but if you rotate it, it would look just like this thing right over here, where one is going straight up and down, and one is going straight right and left. And you can see from our measure right over here that gives us a 90 degree angle, which is it's a very interesting angle. It shows up many times in geometry and trigonometry. And there's a special word for a 90 degree angle. It is called a right angle. So this right over here, assuming if you rotate it around, would look just like this. We would call this a right angle. Right angle. And there is a notation to show that it's a right angle. You draw a little kind of part of a box right over there, and that tells us that this is going if you were to rotate it, exactly up and down, while this is going exactly right and left if you were to rotate it properly, or vice versa. And then as you go even wider, you get wider and wider and wider and wider until you get all the way to an angle that looks like this. So you can imagine an angle where the two rays in that angle form a line. The two rays, so let's say this is point X, this is point Y, and this is point Z. You could call this angle ZX. ZXY, but it's really so open that it's formed an actual line here. Z, X, and Y are collinear. And what we have right over here, this is a 180-degree angle. Or we should say the measure of angle ZXY. Measure of angle ZXY is 180 degrees. And you can actually go beyond that. So if you were to go all the way around the circle so that you would get back to 360 degrees, and then you could keep going round and round and round. And you'll start to see a lot more of that when you enter a trigonometry class. Now there's one last or two last things that I want to introduce in this video. Is there are special words, and I'll talk about more types of angles in the next video. But if an angle is less than 90 degrees, if an angle is less than 90 degrees, so for example, both of these angles that we started our discussion with are less than 90 degrees, we call them acute angles. Acute. Acute. So this is acute. So that is an acute angle. And that is an acute angle right over here. They are less than 90 degrees. What does a non-acute angle look like? And there's a word for it other than non-acute. Well, it would be more than 90 degrees. So for example, let me do this in a color I haven't used. An angle that looks like this, and let me draw it a little bit better than that. An angle that looks like this, so that's one side of the angle, or one of the rays. And then I'll put the other one along the baseline right over here. Clearly this is larger than 90 degrees. If I were to approximate, let's see, that's 100, 110, 120, almost 130. So let's call that maybe 128 degree angle. We call this an obtuse angle. We call this an obtuse angle. The way I remember it is acute. It's kind of a cute angle. It's nice and small. If I believe acute in either Latin or Greek, or maybe both, means something like pin or sharp. So that's one way to think about it. An acute angle seems much sharper. Obtuse, I kind of imagine something that's kind of lumbering and large, and so that's how or you could think it's not acute, it's not nice and small and pointy. So that's one way to think about it. But these are just this is just general terminology for different types of angles. Less than 90 degrees, you have an acute angle. At 90 degrees, you have a right angle. Larger than 90 degrees, you have an obtuse angle. And then if you get all the way to 180 degrees, your angle actually forms a line. Right, what I have right in front of me is the Khan Academy measuring angles exercise. I have a small part of it in this screen right over here, and it's a pretty cool exercise because it has this little virtual protractor that we can use to actually measure angles. And I want to give credit to the person who built this protractor, because I think it's pretty neat. Omar Rizwan, who was actually a high school intern, made this pretty neat module. And so in general, when you want to measure an angle, what you want to do is you want to put the center of your protractor at the center of, or I should say at the vertex of the angle, or you want to put the vertex of the angle at the center of the protractor. And then what you want to do is either rotate the angle or rotate the protractor. In this case, we're going to rotate the protractor. You want to rotate the protractor so that the zero angle, or the kind of the zero mark, is at one of the sides of the angle, and the other side of the angle is within the protractor. So let's try to do that. So maybe we could put, if we want to do that, this zero side should be at this side of the angle. So let's rotate it. Let's rotate it that way. Let me just keep rotating it. Oh, I could just keep it pressed. That's better. All right. All right. That looks about right. So one side is at the zero mark, and then my angle, my other side, or if this was a ray, it points to, looks like pretty close to the 20-degree mark. So I will type that in off the screen. You don't see that, and that is the right answer. And then we can get another angle. So let's try to measure this one right over here. So once again, place the center of the protractor at the center, at the vertex of our angle. We can place the 0 degree, the base of the protractor, at this side of the angle. So let's just rotate it a little bit. Maybe one more time. That looks about right. And the angle is now opening up. Let's see, the other side is pointing to 110 degrees. And so this is larger than 90 degrees. It's also an obtuse angle. The last one was an acute angle. This is obtuse, 110 degrees, more than 90 degrees. So let me type it in. I got the right answer. Let's do a couple more of these. So once again, put the center of the protractor at the vertex of our angle. And now I want to rotate it. There we go. And this looks like roughly an 80-degree angle. Not quite. If I had to be really precise, it looks like it's maybe 81 or 82 degrees. But I'll just go with 80 as my best guess. I got the right answer. Let's do one more of these. So once again, vertex of my angle at the center of my protractor. And then I want to put one side of the angle at the 0 degree. And I want to show you there's two ways to do that. You could do this. You could do just this, but this isn't too helpful because the angle is now outside. The other side sits outside of the protractor. So you want the 0 degrees on the side so that the other side is within the protractor. So let's keep rotating it. There we go. And then our other side opens up, or you could say points to 70 degrees. So this is an acute angle right over here. So it is 70 degrees. So I'll let you leave you with that. Oh, look, I'm ready to move on, the exercise tells me. And now we can start talking more things about angles now that we know how to measure them. This is a video for the Measuring Angles module because clearly at the time that I'm doing this video, there is no video for the Measuring Angles module. And this is a pretty neat module. This was made by Omar Rizvan, one of our amazing high school interns that we had this past summer, the summer of 2011. And what it really is it makes you measure angles. And he made this really cool protractor tool here so that you actually use this protractor to measure the angles there. And so the trick here is you would actually measure it the way you would measure any angle using an actual physical protractor. You'd want to put the center of the protractor right at the vertex of where the two lines intersect. You can kind of view it as the vertex of the angle. And then you'd want to rotate it so that preferably this edge at 0 degrees, is at one of these sides. So let's do it so that this edge right over here is right along this line. So let me rotate it. So then, I got to rotate a little bit further. That looks maybe one more. No, that's too far. So that looks about right. And then if you look at it this way, you can see that the angle, and I don't have my pen tool here, I'm just using my regular web browser. If you look at the angle here, you see that the other line goes to 130 degrees. So this angle that we need to measure here is 130 degrees, assuming you can read sideways. So that is 130 degrees. Let me check my answer. Very good, I got it right. It would have been embarrassing if I didn't. Let's do the next question. I'll do a couple of examples like this. So once again, let us put the center of the protractor right at the vertex right over there. And let's get this 0 degree side to be on one of these sides so that this angle will kind of be within the protractor. So let me rotate it this way. And this really is pretty cool what Omar did with this module. So let's see. Let's do it. Let's see, one more time. No, that's too far. So that looks about right. And then you can see that the angle right over here, it is, if we look at where the other line points to, it is 40 degrees. It is 40 degrees. Check answer. Very good. Let's do another one. This is fun. All right, so let's get our protractor right over there. You don't always have to do it in that same order. You could rotate it first so that the 0 degrees is, and what you want to do is you want to rotate the 0 degrees to one of the sides, but so that the angle is still within the protractor. So let's rotate it around. So if you did it like that, so you don't always have to do it in that same order, although I think it's easier to rotate it when you have the center of the protractor at the vertex of the angle. So we have to rotate it a little bit more. So this is 0 degrees is this line, and then as we go further and further up, I guess, since this is on the side, looks like this other line gets us to 150 degrees. And hopefully you're noticing that the higher the degrees, the more open this angle is. And so this one right over here is 150 degrees. And so let's do that, 150. Let's do one more. Now let me show you what not to do. So what not to do is, so you could put the center right over there, and you might say, okay, let me make the 0 go right over on this side, right over here. So if you did that, notice
your angle would not be within the protractor, so you won't be able to measure it. And what you're attempting to do is measure this outer angle over here, which is an angle, but that's not the angle that this question is asking us to measure. This little arc over here is telling us that's the angle that we need to measure. So that arc has to be within the protractor. So let's rotate this protractor a little bit more. I overdid it. And so this looks like this is 0 degrees, and then this right over here is 60 degrees. 60 degrees. We got that one right too. So hopefully that helps you with this module. That it's kind of fun.